On that note, let me go to Mr. Mark Sokol and see if he is ready. I will ask him to unmute. And again, Jeremy, I can't thank you enough, man. That presentation
Yes, Tim,
was...
I am ready. Let me turn on the volume on this laptop here. Can you hear me?
Yeah. Now, Mark, are you gonna want me to pin screens?
Yeah, so there's two screens to pin. One is Mark Sokol and the other is slow-mo camera. Those are two different views of the experiment that we have going on today. For those in the audience, this is something we only discovered recently. When Tim is pinning these views, it doesn't automatically show up on your screen. So it's all dependent on the settings you have at home, whether you're going to see both those views simultaneously.
Yeah, and Mark, if I could jump in, and this is something Mark mentioned to me, everybody here, you guys will have to do this yourselves. If you look up slow-mo camera, you can find that and pin that view. It's SLO-MO, right? There's no W in it. Or Mark Sokol, or both. And I'm recording this with both of them side by side. So you will see them pinned side by side in the recording. But if you want to see it live that way, you're going to have to view one or the other.
Perfect. Yes. Another person that passed, who I just found out about recently, hasn't presented on the conference, but her husband has. This is Susan Alzofon, David's wife, recently passed as well. And condolences to David on his loss. But it just strikes home the importance of having this conference and, you know, what we've achieved here. We got pretty much all of the big names in alt propulsion, and we put them all together. And me and Tim have been talking about whether we should end the conference on a high note or continue dredging on. And one thing that came to mind was Jerry Seinfeld and his comedy show back in the 80s and 90s. He ended it after just a couple seasons because he ran out of material, and it's been memorable ever since. End at a high note, people remember it well, and we'd rather do that than to continue on and just pull in whatever presenter is available, you know, and lose in quality. The experiments here at the Falcon Space Labs are going to continue. We are going to continue doing live streams both on YouTube with Jeremy Reese and with Bernie's channel on an ad hoc basis. We may use the email list to put out emails for when we have live experiments. But again, a live experiment is very timid. It's dependent on a lot of things. Things go wrong. It's not easy to put together live experiments. Actually, the experiment that we're working on now, we've been working on it for 7 hours right now, preparing it. So this is the latest version of the Podkletnov gravity impulse experiment. Now, I know you guys have watched a couple of variations of this earlier, and we had leaks and stuff. So let me show you the latest updates of what we've done, what we've learned working with this experiment, and what we're doing in order to perfect it. So we have an acrylic tube and a large Helmholtz coil. It's powered by that hybrid battery, nickel metal hydride battery on the bottom. One addition that we've added is the styrofoam over here, which is going to insulate the liquid nitrogen a little bit better, hopefully. Also, the opening where the copper tube enters into the vacuum chamber, that was widened from 3/4 of an inch to 2 inches. It's only a half-inch pipe. So that gives us a 3/4 inch ring of the special epoxy that we're using to decrease the tension on the acrylic, and hopefully it won't crack in this experimental setup. Another thing that we've added, which is very important, we put a conditioning coil inside the vacuum chamber. So that means that there's an extra wire coming out over here on the end. And that coil is going to condition to quantum lock the superconductor as it's going into its superconducting state. And that was critical to the experiment. It's set up right now in the same phase, in the same magnetic orientation as the Helmholtz. So what we're going to be doing is, as we're making the superconductor cryogenic, we're going to be powering that coil. But as soon as we're confident that it quantum locked to that state, we're going to be powering down that inner coil because it will no longer be necessary, and turning on the Helmholtz for the firing. Another reason for doing that is because the Marx gen, which is going to be impulsing that superconductor, will likely short out to the power supply for the coil, and we won't get any spark going in the right direction. So we need all that energy going through the chamber versus coming out through these wires that are powering that inner coil. The inner coil is surrounded by a little piece of insulating foam just to mount it properly. Now, as for the gas that's inside the chamber, it is kind of like a vacuum. It's not a pure, perfect vacuum. Nobody's ever achieved perfect vacuum, but based off of Tony Robertson's suggestion, we did include a little bit of helium in the chamber. So what we've done is we've pulled a vacuum off the air. We've backfilled it with an inert gas with argon. Then we pulled a fresh vacuum, backfilled it with helium, pulled a fresh vacuum again, and backfilled it with helium, and then pulled a fresh vacuum again. And that is where we're at right now. The gauge is right around negative 29.5. I guess that's millimeters of mercury. So another addition that we've added, and this is the first time we've done it. On the grounding end, there is a rod going through, a thick copper rod. So there won't be any ionizing happening on the copper end, on the grounding end, which we've seen in the past. Also, our grounding puck, I don't know if anyone has noticed this in the past, but it is made out of solid silver, and there is a piece of graphite stuck in there as well. Graphite, of course, is a material that has a very high electron drift velocity. So the idea being, add that in and see if it adds anything to the effect. On that goes to a threaded rod on the outside, which is connected to a thick grounding ribbon, which goes to ground, which is also attached to our Marx bank over there. Another thing that we've added, and this is really cool, this is something I was excited about for a while. This is a double laser. These are line lasers, and I don't know how well it shows up on the camera, but those are red lasers, lines that are going to a white piece of paper, basically. And what that will do is, if there is a deformation in space-time, we're going to see it in the high-speed camera looking at that laser light. Now, you're able to see it on the slow-mo camera view right now that I turned on that laser view. So hopefully we'll be able to see something on that. And of course, we also have the hanging lead weights that will be there in case there's any movement as well. So the next thing that we're going to have to do, I'm going to turn this off so that we don't lose the batteries. Everything on this device this time around is going to be battery powered, including the power for the switches, because every time we've had any power supply or anything attached to this thing, they blew up. We have several dead power supplies that were attached that were running a switch. All they were doing is running a switch to connect the battery to the Helmholtz, and all defunct. So we have 2 batteries on the floor for the inner coil. We're using nickel metal hydrate, and for the switch to turn on the Helmholtz, we're using a small lead acid. So the first thing we're going to do is pour some liquid nitrogen and try to get this thing going cryogenic and power up the inner coil. And Tom, you want to give me a hand with this?
Yeah.
Okay.
Yeah. Very good.
Hey, the guys at the store already know me. I'm the superconductor guy. I think I'm the only one who buys liquid nitrogen for them from for playing around with superconductors. Okay, here we go. You can bring the laptop over. You can show everyone the excitement. Oh, another thing, if anyone comes down to the lab and helps out, we're running a giveaway, free Falcon Space t-shirts. A guy showed up earlier today, a programmer was going to help us with that replication of Mike Gamble's gyroscope machine, and he got a free t-shirt. Tim, I know you want a free t-shirt. No. You look too official in the button down. I think we're ready to power up that inner.
Yeah, I'm, Mark, I'm just excited. I'm really excited about I'm really excited that you guys were able to get the vacuum leak repaired. You're pouring it in. It looks great. Everything looks really smooth. That's wonderful, man.
Okay, we're gonna power up this inner coil right now. It is powered up. There's some ice forming on the inside there. Okay. Hope we don't lose any vacuum. That's making noise.
Cracking a little bit. Okay. It's not the acrylic. Vacuum's holding.
The vacuum's holding, okay. We are seeing some condensation buildup, but it's not as bad as it was in the previous shots.
We're putting a lot in there too.
Yeah, we might need a bit more this time because we have that coil there, which is a source of heat in a spot where we really don't want there to be heat. I'm going to bubbling big time.
The bubbles.
Ooh. We might be losing some of our foam. It seems to be holding pretty well. It didn't crack, right? The vacuum's still good.
Vacuum's good.
Okay.
Acrylic is good.
Tim was begging me to test this before. I'm like, Tim, if it breaks, we might only get one shot at it. And I don't want to do that off air. Well, if APEC's going to go out with a bang, maybe this is the bang. Crack.
That was no.
Just shifting a little bit.
Yeah. Vacuum's holding.
Vacuum's holding. That's what counts. There's definitely lots of liquid nitrogen in there.
Oh yeah. Might lose
So we got like 110 turn coil. I think it's pulling around 15 amps right now, or 13 amps, 18.5 gauge. So it might start getting warm. Okay, once you put this back and go get the high-speed camera ready for firing. Tom's gonna be over on the other computer, getting ready for getting set. We're gonna set it on auto trigger. Sorry, guys, can't see me. We're gonna set the high-speed camera on auto trigger. So you won't have to manually be there pushing buttons. Oh, wow. That's bubbling away. Okay, I powered down the small coil. Put a little bit more liquid nitrogen in there just for good luck. With this, with the intercoil power down, we're gonna have to move the leads, remove the leads for it, because those leads are literally direct lines that would allow the Marks bank to short out to the wrong spot, which we don't want. Tom, are you ready yet?
Yes.
All right, Tom is ready, so I'm just gonna pour a tiny bit more.
Don't get the lasers.
Oh, okay, Dan, if I turn the lasers on, I might trigger it.
No, I didn't turn the water pressure on yet.
All right, but everything else is set. What do you have on the price per second set to? What FPS are we at?
We have 1,000.
No, it needs to be much higher than that. You at 33?
Sorry, 10,000, I'm sorry.
Can you do it at 33 or top speed?
38 is top.
38 then. Okay, are you ready?
Yes.
Okay, Tom just gave me the go ahead. We're ready. So instead of staring at me, I'm gonna point it at this. Now, what is gonna happen from past experience, when it fires, we're probably gonna lose the Wi-Fi signal. Okay, we are slowly charging up. Okay, it's gonna fire any second now. Caught it? Which sign are you on now? Oh, so then it didn't catch it. Increase the sensitivity. Sensitivity.
What?
I don't know, down to 5%. You ready? Yeah, I guess. Okay, charging up. Got to increase the sensitivity then. You want to trigger it manually? Yeah, go ahead, trigger it manually. Come on. Are you ready? Okay. Doing it again.
I think he may be hitting the trigger button after it sparks, though.
Yeah, but it saves stuff that happened beforehand too.
Oh, okay. Okay, I got you.
Tom, where's the trigger set point? Is it after? Is it in the middle or end? Good. Here, we're going again. That was a powerful one. Okay, let's keep on going. Okay, charging up. I just realized the Helmholtz wasn't turned on. Now it's on. Okay, we're doing one more. How many more signs do we have? Okay. So, okay. The Helmholtz was not turned on for those previous ones, so it wasn't done right. These last two are going to be correct. Okay, slowly charging up. You got that?
And Mark, Jared was asking if you could lower your arm is actually right in front of it. If you could lower your arm just a bit.
Oh, I couldn't because the first of all, if I put the laptop on top of a high voltage, it loses signal completely. Now I just had to switch the current in order to control that thing. So we got 10 shots of this thing right now, and I think what we got to do is go over to the slow-mo camera computer, and we're going to do the replay right now and see what we got. So without further ado, let's move over there.
Now, so one of the things that I should mention also, Mark, is that I have been pestering Mark. Mark has a Facebook channel. And again, I'm going to give you guys links to all of this. I'll put those in an email. I will send those out, and they'll also be on the website. He has links to all of this stuff. We're going to have this on his Twitter channel, which I've been pestering him to update regularly, as well as Facebook. And so you can follow his continuing progress here. The Falcon Space Team is doing several different projects. Podkletnov is one of them. Alzofon, as most of you guys know, that's another project they've been working on. They have several of these, and these are going to progress over time. They're testing, building, and retesting. So I just want everybody to be aware that he is going to continue putting up information as they create it, right? And this is development over time. It's a wonderful thing.
Yeah, all of these are, works in progress. It's not like this is the end of Podkletnov, although at this point I am confident that this will withstand a lightning strike, which is what we're trying to get with the NTS experimentation. They have a lab where they have a 3 million volt Marx generator capable of like 20,000 amps or something like that. I think at this point, the setup is good enough for that. There's no leaks in it at this point. It went cryogenic. There's no leaks. I believe we got quantum locking inside the superconductor. So all is good on that front. Now, here, so we have 10 different shots to look at here. We'll start with number 10. Now, there's about 3,000 frames in each one. And hopefully we're going to find, oh, there's something there. Is that, no, that's the 60 hertz of the, hopefully we'll see something. Is there an image search? change area. We don't need to drop that down to 1%. Search chapter 1. See if I can play speed and options. So basically we're playing back sine 10 right now. Hopefully we got it. This all happened within this was less than a second for each one. Do you see anything there?
No, not yet.
You very dimly see the laser light.
Should light up with the flash on.
Yep. The flash at this frame rate, 38,000 frames per second, is only going to be about just a couple of images, if it was even captured in this one. Oh, I didn't see anything yet. Here, Tom, you want to? You can do the search for all that. On other fronts, we are going to continue the work here at the lab. I reached out to MUFON, the Mutual UFO Network, and got their field investigator manual to investigate UFO sightings in the area. And I'm going to be joining their class to become one of their UFO investigators. And I told them about the lab, and they're very interested in joining efforts, and maybe we'll have some people from MUFON affiliates who've volunteered their time to be a MUFON investigator. I think that the best kind of investigation is the kind of work we're doing here at the lab, because that's true investigation. Rather than looking at lights at the sky, we're trying to make lights in the lab. Tom, you found anything yet?
No.
Yeah, we're looking through thousands of images right now to try to pinpoint the ones that actually have the light spark through it. This is a very low energy test. It's probably on the order of less than 100 joules of total released energy coming out of that Marks bank. So that is something to note. If you click on play each image,
What is that?
right on top of FPS, up, down, down. Yeah. That'll give you actually every single image, but it takes a lot longer to watch. To rewatch all of this footage will take probably close to an hour. So we could start a Q&A while we're doing it or something, you know, or have some sort of open discussion. And yeah, if we find something, we can.
Well, so what I'm going to do is let me allow participants to unmute themselves then. Do you want to we could just do open discussion. Mark, do you want to take open discussion? And
Yeah, sure. Any questions about the current setup or recommendations or such? Open to hear it. Right now, we're Tom over here is looking over the footage, and you guys can see his screen on the slow-mo camera view, and hopefully we'll capture those few images of the.
It looked like it went right by on the last city that he was looking at.
Oh, you
On
think
here?
you think you saw it?
I saw a flash, but it just went by really quick. But I was watching the slow-mo camera the whole time, and I didn't see it change at all. I mean, I didn't see what was when like it fired. I never even saw a flash on it.
Yeah, you wouldn't, because the refresh time is so slow. These at 38,000 frames per second, you probably only get one image of it firing. Most of the images you'd see are just like afterglow of the ionized air glowing from the high energy.
The trigger was at like 80 to 90%. So like right about now is where it should be showing some.
I think well, let me have everybody first. Let's give Mark, I'm not going to change the screen, but let's have everybody give Mark an enormous applause for this presentation.
Thank you very much.
Mark, you've been working on this.
And
Mark
Tom too.
Well, and Tom too, but they have been working on this thing diligently for months now. It's a very professional setup. I mean, a high-speed camera, the weight setup, the Podkletnov device, testing, retesting, fixing pressure leaks, getting special materials. So Mark, it's a wonderful achievement. Even if you end up with a negative result, it's a wonderful achievement. And I believe as you guys continue to test and retest, you'll start to get results. So, and again, that's stuff that you're just going to continue to put up over time, hopefully, and people can kind of track your progress.
Thank you for that. Yeah. And again, if anyone wants to come down to the lab and help out or work on some experiment they've had, we've had many people here in this Zoom call right now who've come down here in person. Wayne Ojala flew in from Canada. I personally have flown out to many different labs to collaborate. I know Drew in sunny Florida has been asking me to come down there. Maybe we'll do that one day. But Jared is in talks. Aiden Schaefer's been here a couple of times. Charles Crawford has been here as well, helped out, and we met Michael Boyd on the road, and of course our surely Jeremy Reese has been down here numerous times. Jeremiah Pop, who I haven't heard from in a while, he's been down here a couple of times as well, and we've been making this a group effort of having everyone working together on these experiments and pushing things forward. See anything yet? Any other questions? You guys can unmute yourself. Oh, Brian Ritter, go ahead.
Hey guys, I've been following on and off these developments for the last 20 years. I also follow geopolitics, and I have more of a layman's question. I figure since there was an impulse, I could ask you guys, could you gauge how far along we are in the disclosure and acceptance, mass acceptance of these radical technologies that would not only disrupt a lot of science, but everyday life and certainly economics when you're dealing with a petrodollar right now? Energy generation technologies like this would be extremely disruptive. So it is something that I would love to see in my lifetime, but you guys probably have a better engaged on my mind as to how it's going.
So you're asking how far away are we from public acceptance of the technology?
Yes, and out of that, eventually, all the implementations of it.
It depends who's part of this public. Some may say 70 years ago, but if you mean the world in general, I have no idea, because even if we were to make a major breakthrough tomorrow or today, until we build an actual craft could be several years.
I could just add one thing to that. If you follow along with the UAP disclosure stuff going on in the United States Congress, one of the latest developments is that they're trying really hard to give whistleblower protections so that the people who have been working not just for government agencies, but for the private corporations who have these, legally binding contracts where if they come out and disclose what their companies have been working on, like reverse engineering the crafts that they are in possession of, then these people would go to jail or be silenced somehow legally. So it looks like Congress has actually got some traction with this. And if you believe the really big names out there, it sounds like this is something that's actually going to happen in the very, very short term, if not already. Like the documents are already written, the votes for it are already there. I don't know whether or not they've actually taken the vote on it yet, but it sounds like they're going to, and it's going to pass like within the next few months, if not this month. So as far as this rate of disclosure goes for the technologies, as soon as they come out and say, we've been reverse engineering downed UFOs, that should really open the floodgates with all of the people who are going to be free to come forward to say, yeah, and I was one of the engineers, and this is what was going on with it. So as far as warp drives before we die, I got really high hopes.
Well, if I might add something, I think that we're about 24 months away from the US dollar not being the leading force behind world economics. And that opens an opportunity for the petrodollar to be disbanded for switches in energy generation, for petroleum to be taken out of the major role it plays right now in that area within a window of economic opportunity where it probably wouldn't completely disrupt world economics, because they would already be disruptive anyways.
Potentially, because the Saudi princes, the Saudi government, they have so much more oil reserves under their feet that they still haven't sold yet. A lot of folks say they still have hundreds of years of oil still there, which means that's an asset that I'm sure they would love to protect, which means that they rely heavily on the petrodollar as well. And considering the US sells them weapons that are enough to take over countries, I can't imagine that the petrodollar is going to die overnight. If it does happen, the slow grind, in my mind, means there's going to be a really strong fight that would involve lots of bloodshed and war.
Guys, even if they stopped using gasoline tomorrow to move cars and trucks, the petrodollar isn't going anywhere. The companies that crack oil, the producing fuel is an annoyance to them. There's more money in plastic. So they're going to be cranking out oil for the next 100 years to make plastic, trash bags. So, if they cracked fusion tomorrow, or we get warp drive that drives, propulsion systems or whatever, it's not going to change the big boy game.
I believe plastics, though, and other commercial uses of petroleum only account for about 4% of the world's consumption. So if we had something that replaced energy generation and transportation and all that, that level of disruption of 96% removal, that I don't care if you start quadrupling your plastic production, it still is going to mean the death of many economies.
Yeah, but it's mainly natural gas in America that we're running on.
So Wayne is asking if he can, Wayne is asking if he can do his presentation on Alzofon videos now. And that would be up to you whenever you're ready.
Sure. You know what? This is going to take a while to go through all the footage.
Okay,
So
let me go to
start, and then maybe we'll come back to this, when we get those images. And
okay, so I'm going to remove the pin there. I will remove both pins. Let me go to Wayne.
Tim, can I just jump in and give a 2-minute update? Because I'm gonna pop it off to go get some ice cream.
Sure, yeah, go for it.
Okay, I don't mean to mess up anybody's night, but we've got some pretty big things going on here in sunny Florida. I just thought I'd ping in. The biggest thing is we got funding. So we're shutting down the home lab, and we're opening up a full-blown operation commercial lab. We're going to have a research division. We're going to have an engineering division, and of course our business division. And we hope to be in the sky with our prototype satellite in 24 months. Prototype satellite's going to be something like a U3, maybe a U6, and it's going to have between 1 and 2 newtons of massless or propellantless propulsion. So we're really stoked about that here. And the vapor deposition chamber system is fully operational, and learning a lot about depositing materials. So
awesome.
If anybody plans on visiting sunny Florida, they might want to do it sooner rather than later, because the new shop is not going to be open to the
Well, and
public.
Drew, maybe you can drop your email or drop some contact info into chat, and that way people can use that.
Okay.
Okay. So
Sure.
yeah.
Thanks.
Well,